The next unit that we are working on, systems of equations and inequalities. So we will be on this for pretty much the rest of the semester in this unit.
Is it easy?
It's not bad.
So no.
Okay,
What's harder, this one or
probably the last one.
last one was different?
Okay, so systems of equations. We have looked at equations before. We have looked at inequalities before. A system is basically two or more equations. With the same variables. So in a system, we are putting multiple equations together, but they will have the same variables in them. So they will have x's and y's. We're not going to have an equation with an xy and the next equation have an ab in it. Just one set of variables that we're looking at. When we are looking at these, a solution is going to be a point where two lines intersect. And that's what we're really going to focus on today. We'll be graphing both of the lines and looking for where they hit each other. That is the solution of the point. In algebraically, that point is whatever point that makes both equations true. So it's like finding an ordered pair where both equations would be true at the same time. When we're looking at these, we're only looking at systems of equations involving lines. So I'm not going to give us anything too crazy. If you're looking at two lines, then your options are either you have two lines and they meet somewhere. Those are intersecting lines. They have one solution. Whatever that point is where they meet, that ordered pair is the solution. It makes both of them true at the same time. Sometimes we might have parallel lines. What do I mean by parallel lines? Yeah, they're the same slope, they never meet. So if I'm looking for the solution, that's the intersection point. There is no intersection. So it is no solution. There is no ordered pair that makes them both true. The final option might be I give you two equations, and when you go to graph them, they are the same line. You graph them and they're both the same, two equations of the same line. And so in that case, it's infinite solutions. Any ordered pair you pick on the line makes it true. So for now, we're just going to write that. You can write infinite solutions. You can do the infinity symbol. It's kind of like a sideways H or two circles touching each other. It's just saying any point on that line would make them both true. So those are the only three situations we might encounter today. We're going to look at a different strategy for solving these each day. So today, our focus will be solving by graphing. So if we're going to solve by graphing, the first step is to rewrite the equation in slope intercept form. So slope intercept, remember, y equals mx plus b. That's the form we liked things in the first unit when we were graphing lines. We always put them in that order because it was easier to graph. Then we graph. Remember, we start at the y-intercept, put a dot there, then do slope, rise over run to get the second point. So we'll put both of them in that form, graph both of them, and then the final thing, we have to identify the solution. So we'll have to write the ordered pair. That is the solution. Alright. So let's try some. So we have to graph both lines here. The first one, y equals x minus 8. That is already in slope-intercept form. So remind me, how do we graph things in slope-intercept form? What do I do first? Where would my first point go? Negative 8. That's my y-intercept. So I hit my y-axis at negative 8. And then my slope, that's the number in front of the x. What's the slope if there's nothing there? 1. So from that point, we go up 1 over 1. Rise over run. Okay, you guys have a ruler, so now you can draw a straight line. I'm just going to put a bunch of points here because I can't draw straight lines on here very well. And let's see what we do. The thing about these solving by graphing, your graphs have to be perfect for it to work. If one of your lines is a little bit off, you will not get the correct solution. So we need to be very careful on those. Now we do the second one. It is also already in slope-intercept form. So where's my first point go? At 1. My slope is negative 2. What does that mean? Okay, you could think of it as like a negative 2 over 1 or a 2 over negative 1, either way. So you could go up 2 and backwards 1, or you could go down 2 and right 1. Your ruler to draw a perfect line. Okay, so the solution to the system. It's like saying if I have both of these equations at once, where do they meet? So if I look, what is the point where these two meet? X, Y. Positive 3, negative 5. Is that what you guys got? Looking at your graphs. So you do have to write that solution down. You need it right there to show where they meet. And you can check these solutions if you plug them back in. If my x is 3, is 3 minus 8 equal to negative 5? Yeah. Is negative 2 times 3 plus 1 equal to negative 5? Yeah, so it works for both. You guys see how I just checked those? Putting them into the original. Let's go to, well, why don't you guys try number 2? We'll do another nice one before we throw anything else in. We have some different answers on this one. The first one, what is my y-intercept? 9. So I start at 9. Slope is 1/2. So up 1 over 2. Down 1, backwards 2 would also work. And then you have to draw a perfect line because if your line is even off by a little bit, you won't be able to get the true point where they meet. All right, second one. What's my y-intercept? 6. What is my slope? Negative 1 over 1. So you can go down 1 and right 1, or up and left. Hopefully yours are slightly better. It is really hard to draw them up here. Okay, so this is the point where they meet. What is that ordered pair? My x is -2, and my y is 8, -2, 8. If you guys aren't sure, you know, if you have a line like mine, it's not perfect, you can check them. Just plug the -2 into the first, you get -1 plus 9, which is 8. You plug -2 into the second, you get 2 plus 6, which is 8. So we see it does work for both. We have the right spot. Okay, how is this problem different? Right, this is not slope-intercept form. So let's look at the first one. -3x plus y equals 8. So if I want y by itself, I have to add the 3x. So y equals 3x plus 8. So to graph that, we start at 8. I don't have room to go up 3, but we could go down 3, back 1. Our first line. Second one, what would we do? We get y equals x minus 2. And so we start that. Y-intercept is -2. Slope is 1, so up 1 over 1. So the point where they meet is -5, -8, or -7. 5, -7. Probably going to do 3 more, and then I'm going to stop. Okay. What's wrong? That's what I have. All right, number 4. The first one, we have to get it in y equals mx plus b form. So what do I do to that one? Huh? So that would be 2y equals -x plus 4. And then what do we do to everything? Divide by 2. Do you guys remember doing this in that first chapter? So we get y equals -1/2 x plus 2. Okay, look at the second one. Do we have to do anything to it? No. Do you notice anything right now? They're the same. We still have to graph it. So it's a y-intercept of 2, slope 1/2, so up 1 over 2. But since they're the same line, I really only have to graph one. So what's my solution? Infinite. Every point on that line is a solution. They are the same thing. So any point on that line works. Alright. We're going to do 5 and 6 because they each have a little something different with them, and then I'm done. What's different about number 5?
First one is
Okay, first one isn't slope intercept form. How would I get it? Everything by 3. So I'm going to write that as a negative 1/3 x minus 5, like we did in that first chapter. So y-intercept negative 5. And go down 1 and right 3. Or up and left. The second equation is why I wanted to do this example. What is different about that second equation? Doesn't have, yeah, not the y equals mx plus b. If it's y equals a number, what kind of line is it? Horizontal. If it's x equals a number, it is vertical. So we could have those. So y equals negative 7 is just saying you have a horizontal line at negative 7. So they meet at the point 6, negative 7. Any questions about that one? Yes.
How do we have to do those numbers out?
The ordered pair at the end. If your lines aren't meeting up where they're supposed to, do more dots for your slope, like I'm doing. So, number 6. If I graph this one, we start at 5. What's my slope? 1. So up 1 over 1. So if your lines are not meeting right, just keep going up 1 over 1. Give yourself more points to help draw that straight line. But we are seeing right now the big downside to solving by graphing. Your graph has to be perfect for it to work. So that's why tomorrow we're going to talk about other options. I'm impressed with myself. All right, the second one. What would I have to do here? Okay. So I have negative y equals negative x plus 2. divide by -1. So y equals x minus 2. So I start at -2, slope is 1, so up 1 over 1. And if you're struggling with that, just keep putting those points, up 1 over 1. Got 'em. Yeah, what did you say about those lines?
Parallel.
They're parallel. How can you tell from the equations that they're parallel? Yeah, the slope is the same. So they never meet, so what's my solution? Yeah, it's an empty set, no solution. There is no point where they intersect.